Hello guys, in this video we are going to solve integral e to the power of x into x squared plus 1 over x plus 1 perfect square. As the first step, we should get partial fraction of the x squared plus 1 over x plus 1 perfect square. In this fraction, highest degree of the numerator is 2. Highest degree of the denominator also 2. So we can start with the constant value. We can put capital A. After that, in the denominator, x plus 1 perfect square is a repeated value. So we can write b over x plus 1 plus c over x plus 1 perfect square. Here, capital A, B and C are constant to be determined. Now we can multiply all the terms from x plus 1 perfect squared. Then we can write an identity x squared plus 1 equal to a times x plus 1 perfect square plus b times x plus 1 plus c. X plus 1 perfect squared we can write as x squared plus 2x plus 1. After that we can remove the brackets and we can write x squared terms together, x terms together and constant terms together. So we have an identity x squared plus 1 equal ax squared plus 2a plus b times x plus a plus b plus c. After that we can compare the coefficient of x squared. Then coefficient of x squared left hand side 1, coefficient of x squared right hand side capital A. So we can find the value of capital A. Similarly, we can compare coefficient of x. In the left hand side, coefficient of x 0. In the right hand side, 2a plus b. We already know value of a, so we can find the value of b as minus 2. We can compare coefficient of x to the power of 0 or constant terms. Left hand side 1, right hand side a plus b plus c. We already know value of a and value of b, so we can find the value of c as 2. Since we know value of capital A, B and C, we can write the partial fraction of the x squared plus 1 over x plus 1 perfect squared as 1 minus 2 over x plus 1 plus 2 over x plus 1 perfect square. Let's move to integration part. Instead of x squared plus 1 over x plus 1 perfect square, we can write partial fractions. After that, we can remove the bracket. First one, e to the power of x into 1 minus second one, 2 into e to the power of x over x plus 1 plus third one, 2 into e to the power of x over x plus 1 perfect squared. After that, we can consider integration sign separately. First one, integral e to the power of x. Integral e to the power of x we can write as e to the power of x. In the second one, 2 is a constant. So we can bring outside of the integral this value of 2. In the last one, 2 is a constant. So we can bring outside of the integral this 2 value. E to the power of x over x plus 1 integral we can write as integral e to the power of x into x plus 1 to the power of minus 1. To simplify this integral, we can use integration by parts method. We can give priority for e to the power of x. Integral of e to the power of x we can write as e to the power of x. X plus 1 to the power of minus 1 we can write as it is. Minus integral e to the power of x into now differentiation of the x plus 1 to the power of minus 1. X plus 1 to the power of minus 1 differentiation we can write as minus 1 x plus 1 to the power of minus 2 into differentiation of the x plus 1 we can write as 1 plus 0. In the integral, minus 1 is a constant. So we can bring outside of the integral this minus 1 value. After that, we can write x plus 1 to the power of minus 2 as 1 over x plus 1 perfect squared. Then we can remove the brackets. First one, minus 2 e to the power of x into x plus 1 to the power of minus 1 minus 2 integral e to the power of x over x plus 1 perfect squared. Now we can cancel out minus 2 integral e to the power of x over x plus 1 perfect squared value for positive 2 integral e to the power of x over x plus 1 perfect squared value. Then we can get final result as e to the power of x minus 2 times e to the power of x into x plus 1 to the power of minus 1.